Hi everyone. In this video, we will learn about what is insertion sorting algorithm and how does this algorithm works and how to implement this algorithm in Java. First of all, let us see how this algorithm works. Imagine this as an array of integers. Here you can see a integer value which are the index of the elements. First of all, insertion sort starts with the first index of the array. It will place the value in the first index in the temp variable and compare the temp variable with the elements present in the left to the index. Now I is the starting point of the iteration and j represent the elements in the left array. Now we will place the value 2 in the temp variable and we will now compare the value in the temp variable with the left array. The first left value to the index 1 is 3. Since 3 is greater than 2, we will move it to the right and then we will move to the next element. Since there is no element left in the left side array, we will place the element 2 in the 0th position. Now this position can be tracked using the variables of j and I. So to track the position of insertion, we will use the variable j and I to track it. In the next iteration, we will start with the index 2 and place the value of index 2 in the temp. Now compare it with the left value. 3 is less than 4. Therefore, we will not move it to the right and we will insert the value in the second position which is tracked by j. We will always insert the value in the temp to the array in the position of j plus 1. To track this, we will use the variable j. Next iteration, we start with the index 3. Place the value 9 in the temp variable. Compare it with the left value 4. Since 4 is less than 9, we will not move it. And we will insert the value 9 in the third position, which is j plus 1. And the next iteration, we will start with the index 4. Place the 7 in the temp variable, compare it with the 9. Since 9 is greater than 7, we will move it to the right. And now compare it with the next left value 4. Since 4 is less than 7, we will not move it to the right and place the value in the position 3, which is j plus 1. In the next iteration, we start with the value 5, index 5, and the value 6 is placed in the temp variable. Compare it with the left value 9. Since 9 is greater than 6, we will move the value 9 to the right. And the next left value is 7. Since 7 is greater than 6, we will move it to the right. The next left value is 4, which is less than 6. Therefore, we will not move the value to the right and we will insert the value in the position of 3, which is j plus 1. In the next iteration, we will start with the index 6. We will place the value 1 in the temp variable, compare it to the left value 9, which is greater than 1, move it to the right. The next left value 7, which is greater than 1, move it to the right. The next left value is 6, which is greater than 1, move it to the right. Then 4, greater than 1, move it to the right. 3, also greater than 1, move it to the right. And 2, which is greater than 1, move it to the right. Since there is no element left in the left side of the index, therefore we will insert the value 1 in the 0th index which is tracked by the index value j. The next iteration we will start with the index 7. Place the value 8 in the temp variable, compare it to the left value 9 which is greater than 8. Therefore we will move it to the right. Now the next left value is 7 which is less than 8. Therefore we will not move the value 7 to the right and we will insert the value 8 in the position 6 which is tracked by j. Now we got a sorted array. So this is how insertion sort works, and now we can implement this algorithm in Java. So first of all, I'll declare an array, also give some values, which is an unordered array, unsorted array. Okay, now let me create a for loop with int I equal to 1. So why I equal to 1? Remember, insertion sort always starts with the first index of the array. Therefore, I am giving the value 1 to the variable I, and I is always less than array dot length, and then I plus plus I increments. Now already have a bracket. Now I'll declare the variable temp. Also, the value of temp is the value of value in the ith index. So a value in the ith index. Now I'll also declare the variable j, which is I minus 1. Since it is a previous element to the ith index, we will give j as a I minus 1. Now I'll create a for loop, while loop. So there are two conditions I need to give. The first condition is j should always greater than or equal to 0. Why? Because if j is less than 1, there is no index that numbered with minus 1. Therefore, we constantly need to check whether the value j is always greater than or equal to 0. And the next condition is array of j, the value which is left should be greater than the temp variable. If both the conditions are true, then shift the value. Okay. After shifting, we need to decrement the value of j. Yeah. So at last, we need to insert the value temp. So where we need to insert the value temp? If you remember, I have said that the position of insertion is tracked with the value of j. So therefore, AR of j plus 1 is where we need to insert the value temp. Now let me print system dot out dot println arrays dot toString method and array. So let me run it. So Java C test dot Java and then Java test. Yeah. So therefore you can see that the array is of ascending order. You can also sort the array in descending order by changing the greater than sign as less than sign. By changing the sign, you can sort the array in the descending order. Yeah. So this is how insertion sort works, and the time complexity of insertion sort is big O of n square. So this is the time complexity of insertion sort. In the next video, we will see about more optimized sorting algorithms like merge sort, quick sort, and I would like to also cover heap sort also. So that's it for this video, and I'll meet you in the next video. Thank you.